Selection Bias by Pamela Haysom for HEA 201. Okay, so let's start with the basics of exactly what is bias. Bias is a tendency to make data give a different answer to what is the truth. So if you want to avoid bias in your study, you won't select a biased sample or allocate subjects to biased groups. As can be seen from this graph, data can be made to show almost anything you want it to. So if you believed this graph, you would believe there was a relationship between eating cheese and dying from becoming tangled in your bed sheets. So it is important to check for bias. Now to move on to selection bias. Selection bias is where there is a difference between those who are selected and those who are not selected. An obvious example would be to choose only healthy individuals for control subjects, but to use a mix of healthy and diseased for test subjects. This could show an exaggerated effect for the exposure in the final outcome. This can be more of a problem with case control and retrospective cohort studies, where exposure and outcome have already occurred at the time individuals are selected for study inclusion. Prospective studies, particularly randomized controlled studies, where the outcome is unknown at the time of enrollment, are less prone to selection bias. When sampling is done, it is important that it is even and representative of the population being studied. This table shows an example of unbiased sampling, which is an even distribution of subjects taken from all sectors of the study population. In this table, we see an example of biased sampling, in which a non-representative distribution of subjects has been taken from the sectors of the population. Unequal proportions have been taken from each section, and an increased proportion of diseased and exposed subjects have been chosen over the rest. This will put a bias on the result of the study. The groups should be as similar as possible at the start of the research, so that any change during the study is more likely to be due to the intervention being studied, rather than differences between the groups themselves. Selection bias may be minimized by using stratified, random assignment of subjects, which is done by dividing the entire population into homogeneous groups called strata. Random samples are then selected from each stratum. In the example shown here, the subjects have been divided originally by sex into male and female, and then by age. Each stratum are equally represented into each treatment group. Biased sampling causes study results to become unreliable and limits its use. A study with unbiased sampling supplies information which can be related back to the population that was being studied and is useful in some way. In a study by the British Royal Air Force during World War II, it was found that returned aircraft had received damage to the nose, wings and tail. It was originally decided to add more armour to this part of the plane, until an Austrian economist, Abraham Wald, looked at the data and said to do the opposite, and to add armour to the body and rudder, as are circled in green in this diagram. His recommendations saved many lives. In summary, study groups are to be representative samples of the population being studied. They are to be randomly and preferably independently allocated to trial groups. When a study starts out with dissimilar groups, the results at completion become very hard to interpret. They may be due to the exposure, or they may be due to the fact that the groups were different from the start, and this is known as selection bias. Thank you for listening.